started. Like that, 1.1, 1.2, 1.3, like this. Again here, even 1.1.2, 1.1.1, 1.1.2, like this also it was there. So it is first version, later second version, third version, fourth version, fifth version, like this. Many versions are there. If any little bit modifications are there, here changed. Little more changes are there here. Many changes are there here changed. Like that. So JDK 1.02 latest version, 19 version is there. JDK 19. Okay. See, starting JDK, now latest JDK. So many changes are there. The changes also 3 categories divided. 3 categories. One category language. One more category library. One more category JVM. 3 categories of changes will be there. 3 categories of changes will be there. One category library, one category JVM, one category language. 3 changes. So Java changes. If any modifications are there in a library, then new version comes. If any updations are there, new version comes. Existed features also modified or new features added, and some features may be removed. Then new feature introduced. Okay. When new feature will come is, there are 3 reasons. One reason, if they want to add new feature, if they want to add some other feature, then new version comes. If they want to modify existed feature, already feature is there, you want to modify something, then new version comes. And if they want to remove, then also new version. So existed features may be removed, existed features may be modified, or new features may be added. That type will be there. Okay. Those are 3 categories divided. Language changes, library changes, JVM changes. Language changes you have to learn. Library changes, JVM changes, no need to learn. Library every day they'll update. Library. JVM internals every day they'll update. That is no need to learn. Okay. Language changes you have to learn in a core Java. But in advanced Java, library changes also you have to learn. If any important library changes. Because advanced Java means only library. Language already core Java concept only language. Up to exception handling language. After exception handling application development. For that library required. So in advanced Java, language will not be there. Advanced Java only library. See, every day, any advanced Java program you observe. Any advanced Java program you observe. Here, every line, every word, every line, every word, every line, every word, it appears core Java only. Okay, every line, every word appears core Java only in advanced Java. So any advanced Java program you start. First, import keyword appears. Import keyword is core Java or advanced Java? First, package keyword appears. Class, try catch blocks. So here, these all concepts you observe. Anything you observe. Package keyword, you already studied. Import keyword, already studied. Public keyword, already studied. Class keyword, already studied. Main method, already studied. Try catch blocks, already studied. Now, for name is a static method. That concept already studied. For name method in class. That is your calling. Here, driver manager dot get connection. Concept you studied in core Java. Library class name is advanced Java. So, every line, every word, core Java concept only. Okay. Up to exception handling in core Java, whatever you studied, that is called language. With that language, you are going to develop applications. For developing applications, library required. That library you are learning in advanced Java. That's it. Now you want to establish a connection between Java application and database. Language already over. What you learn in advanced Java? Library. That is advanced Java. That's what language, if you are familiar with that knowledge, how to access library, you will get it. Once if you know how to access library, any Java program you can write. With that language knowledge only, you can access library. And with that knowledge, any program you can write. Now, say JDK 1.0 to JDK 19. So many changes are there. You studied in core Java classes. JDK 19. Okay. Java 8 only. Many changes are there. 10 plus changes are there in Java 8. Java 8 only, so many changes are there. Java 5, Java 7, Java 9, Java 8. These all many changes are there. Okay. Up to JDK 19, you studied. All features you studied. JDK 19, up to JDK 19, JDK 1.2, 1.0 to JDK 19, almost 25-30 features are there. Those all you studied. Like that, JDBC changes also are there. JDBC versions. Okay. Now, here, JDBC 1.0. Later 1.1, 1.2, 1.2.1, 1.3, 1.4, like that, many are there. JDBC 2.0. Again 2.0, 2.1, 2.3, like that, many came. JDBC 3.0. JDBC 4.0. Present JDBC 4.3 going on. JDBC 4.3, latest version. That is 2017 only introduced. So almost 6 years over. 6 years back, JDBC latest version. Later, no changes. Okay, no changes. Because nowadays, all are using in frameworks. That's what changes are less. Changes are less. Versions are not increased. Same 4.0, 4.1, 4.2, 4.3 came. Now, 1.0 initial specification. Okay, first specification. So, here versions, here new features. Versions, new features. Like 1.0, that is first version. The total JDBC new only. In a first version, total Java 1.0. Java 1.0, total Java is new only. Okay. Next version onwards, new features comes. So JDBC 1.0, it is initial specification. JDBC 2.0, some changes are there. Some new features added. That is only you learn. Result set, enhancements. It was not there in 1.0. It is introduced in 2.0. Batch processing. This was not there in 1.0. Later introduced. Advanced data types. Blob and clop. It was not there. Later introduced. Okay. Let us advanced features, data types. JDBC 3.0. Row sets. Here row sets came. Here save point in transaction management. Okay. See, these are the new features. Like here, one more feature here introduced JDBC 4.0. Auto loading driver facility. Auto loading driver class. See, these are the features came. 1.0 to 4.0. Just note on these all. Versions, new features. So JDBC 1.0, JDBC 2.0, JDBC 3.0, JDBC 4.0. JDBC 1.0, it is initial specification. That means first specification. JDBC 2.0, 3 features added: result set enhancements, batch processing, advanced data types, blob and clop. JDBC 3.0, 2 features added: row sets, save point in transaction management. JDBC 4.0, auto loading driver class. Auto loading driver class. Driver no need to load. It is automatically loaded. Class dot for name we written, no, that is no need to write. Oracle.jdbc.driver.oracle driver we are writing that line. That line no need to write actually. 4.0 onwards. Auto loading driver class. JDBC 1.0, JDBC 2.0, JDBC 3.0, JDBC 4.0. So up to exception handling, most important in core Java, as well as collections framework and generics. That is most important topic in core Java, as well as Java 8 features. Those are most important. As compared to advanced Java, core Java most important. That is remember. Core Java only most important as compared to advanced Java. Java up to exception handling important. Collections framework and generics, that is important. Java 8 features, that is also Lambda expressions, method references, predefined functional interfaces. You studied, no? Those all. Stream API, those all most important. Okay. Functional interfaces, functional interface annotation, those all most important. See 1.0, 2.0, 3.0, 4.0. Like this, JDBC new versions, like new features added. Now in this 1.0, I taught 2.0 result set enhancement completed, batch processing completed, advanced data type completed, row sets completed, save point also yesterday completed, auto loading driver class. This is no need to write. That is only just write it. Auto loading driver class. Auto loading driver class. This feature loads the JDBC driver class automatically in a Java program. This feature loads the JDBC driver class automatically in a Java program. It does not require to write class.forName statement. It does not require to write class.forName statement. Now, class.forName no need to write in the program. It will be loaded automatically. With that also connection established. Without writing that line only loaded. Based on URL, it will understand. So this feature loads a JDBC driver class automatically in a Java program. So it doesn't require to write class.forName statement in JDBC program. It does not require to write class.forName statement in JDBC program. No need to write. This is auto loading driver class concept. Automatically driver loaded. So in previous program, every day we return class.forName. That is actually not required. Not required. Without writing, it works. See here. I'll remove these all. You observe one message. Connection established successfully. Like this, I written one message. If I run this program, see class.forName, I'll remove. This class.forName, I'll remove. See, only driver manager dot get connection, I written one line. You observe. No, it doesn't require. Only SQL exception enough. Right click, run as Java application. Save. See, connection established successfully. But here class.forName is not there. So this is 4.0 feature. Up to JDBC 4.0, we written JDBC 4.0 onwards, not required. That line is not required. Okay. Now automatically driver loaded. That's what not required. In a row sets you studied. JDBC row set JRS equal to new Oracle JDBC row set. In that also automatically loaded. There. In that constructor only they written. That is Oracle class, Oracle purpose. This is automatically loaded based on URL. It works. Okay. This is JDBC. If you want, like here, dynamically we accepted data with command prompt. But dynamically, if you want to accept the data, there are so many ways are there in Core Java class you studied. Dynamically, if you want to accept the data, command line arguments I taught. Command line arguments. Okay. Second one, scanner class. Scanner class also we can use, no? Third one, system.in.read. This is also you can use, no? Fourth one, buffered reader. Buffered reader also useful. And fifth one, data input stream. Also useful. Okay. With command line arguments, you can accept the data dynamically. That is I taught in the programs. In a prepared statement, callable statement. While teaching, I given command line arguments. Args of 0, args of 1, args of 2, like that I given. No? So accepting data dynamically, 5 options are there with Core Java. One is command line argument, one more scanner class, one more system.in.read, one more buffered reader, one more data input stream reader. What's the difference? These all? But all are possible, no? Scanner class possible, command line arguments possible, system.in.read possible, buffered reader possible, data input stream possible. What's the difference? These all? Now, command line argument, which format received? String format only received. Whatever you want, you can enter. But received which format? Only string format. String format you have to convert into according to your requirement. Suppose string to integer, how will convert? Parse in. String to float, parse float. String to double, parse double. Like that, you'll write. Okay. Like command line argument, always it will accept the data string format only. String format to other formats, you have to convert explicitly with parse in method, parse float method, parse double method you'll use. Okay. System.in.read, which format it will take? Which format it will take? Byte array. It will take only byte array. It will take only byte array. Again, what you have to do? Byte array you have to convert into string. String to integer again. It is what? 2 times, 3 times you have to convert. That's what? That is no one is using. Okay. But actually that is only main. Based on that only remaining all working. If you want to use buffered reader. Now, if you want to use buffered reader again string format will read. But string to again you have to convert. Data input stream. Primitive data types it will take. All primitive data types. Integer, character, float, double, these all. Scanner class. That is also same style. Integer, character, float, double, all possible. But in all, which is easiest? Scanner class. That's what all are using, scanner. It is 1.6 released. Previously, it was not there. JDK 1.6 scanner class came. Okay. Here, if you use command line arguments, conversion required. That's what no one is using. And if you use system.in.read, again conversions required. That's what that is also not in use. If you use buffered reader, again conversions required. That's what not in use. Data input stream and scanner class better. But data input stream, again it will throw exceptions, try-catch blocks also you have to write. But here exceptions also not there. Scanner S equal to new scanner, right? No? That is. Now many people ask her to explain again exception scanner class. That's what I'll explain. With scanner class how to accept data. Suppose you want to insert query. Insert into student values. Question mark, question mark, question mark. Now this data how to accept, many ways are there. I taught with command line argument. Now with scanner class how to accept. That is I'll explain. One scanner class program. See, one program I'll explain, later you can do it. Scanner class. With the scanner class, how to accept this data. Like in a, how to pass in a query. How to pass in SQL query. With how to accept scanner class. How to pass in SQL query. That is I'll explain. Okay. See, first, scanner class methods are there. Scanner class. You see. Here you observe Java P, java.util.scanner. Okay. In scanner class, see, next byte if you call, you will get a byte. Like next short if you call, you will get a short. So next int if you call, you will get a int. Next long if you call, long. Next float, float. Next double, double. Next, if you call, you will get a string. Next line. 2 methods are there. Okay. See, next line, string. Next also is there. Next. Okay. Next method also is there. Next method also you can use. That is string only returns. So next method, one string. Next line method, one line of string. Like that, accepted. Okay. Now these methods, if you want to call, you have to create scanner class object. You have to create scanner class object. Say next method. This next method, one string. Next line method, one line of text. Like that, we can use. But scanner class object you have to create. For creating scanner class object, we are using this one. Now, first, what you will do if you want to accept, write scanner class. Now, what you will write? Scanner S equal to new scanner. Now, system.in. But actually, scanner class consider what it takes. What is the parameter? Input stream. Input stream. But what we are passing? Is it valid? But actually what it takes? Input stream. Input stream object or input stream reference you have to pass as a parameter. Now, why we are writing system.in like this? Now, input stream, now parameter is input stream. Parameter is input stream. Input stream object or input stream reference we have to pass. Now, input stream. What is input stream? You observe. Input stream is a public abstract class input stream. Input stream is abstract class or concrete class? Can we create object? But how it is created? You are passing everyday system.in, system.in. But how it is working? Input stream is object class, abstract class, no? Can we create object to abstract class? No. But how it is working? Input stream object you cannot create, no? Input stream is abstract class. Input stream is abstract class. So majority students, what they are doing, they are by-hearting that line. Scanner is equal to new scanner system.in, over. If program is working, okay. But how it is working? Majority people, they don't know. So here actually, you see the method java.util.scanner class constructor. Here scanner class constructor takes parameter is input stream. Parameter is input stream. Input stream object or input stream reference we have to pass. Either input stream object you have to pass or input stream reference you have to pass. But input stream is a abstract class. Can we create object to abstract class? No, you cannot create object to abstract class. Okay. But can we create reference to input stream? Yes or no? Yes. Reference we can create. Object we cannot create. Interface also, abstract classes also, we can create references. But we cannot create objects. Abstract classes cannot be instantiated. And the interfaces cannot be instantiated. We cannot create object to abstract class. We cannot create object to interface. But references we can create. That means the reference points to subclass object. Now, input stream, actually, input stream is a one class. Input stream is a class. From this, one class derived, buffered input stream. This class. It is superclass. It is subclass. Now, can I create object like this? Can I create? Yes or no? Here, which class object created? Which class object created? Buffered input stream object created. That object referred by input stream reference. So here buffered input stream object created and assigned to input stream. Okay. Now this concept is called upcasting. Subclass object, subclass reference assigned to superclass. This in is that in. You are writing in nothing but it refers buffered input stream object. That is, you can see, you can find out. Just if you print this one, say you observe, I'll remove this one. Just you observe system.out.println system.in. If I write, you'll get a hash code, no? Whenever you pass, suppose, if you write, suppose here, connection demo cd equal to new connection demo. Now system.out.println cd. What is output comes? Hash code. Actually here implicitly which method called? ToString method. Which class ToString? Object class ToString. With that hash code coming. You observe. You'll get a hash code. Class name printed in hexadecimal format. Hash code also printed. Now, 1 minute. These all not required. Okay, just exception I'll write. That leave it. Now, That is not required. Okay. Right click, run as Java application. Now what you are getting, see, JDBC package name. JDBC is a package name. Connection demo is a class name. At hexadecimal format, hash code. Hash code is printing. Okay. Now here, whatever you pass here, that object class name it prints. So that class name prints as well as hash code printed. Hash code hexadecimal format printed. Implicitly .toString method called. If I write toString also, same output comes. You observe. Right click, run as Java application. Save. Same output. You observe. See, connection demo at hash code. So you studied in the total Java, which is a default package, java.lang. That package implicitly imported in every Java program, which is a default class, object, that is implicitly inherited in every Java class, which is a default method. Main method is that is different. ToString. This ToString, no need to call. It is default method. Okay. Main method is not a default method. Main method every day we are writing, no. If it is default, why we will write? Every day we are writing. Without main method, will it compile? No. It every day we are writing. It is not a default. This is default. If I write also, if I don't write also, same working, no. So default method is ToString method. In a collections also, exceptions also, every day ToString method implicitly called. So one default package, one default class, one default method. Java.lang is a default package. Object class is a default class. ToString method is a default method. These are default. No need to write. Extends object, is it required to write? No, implicitly comes. .toString, is it required to write? No, implicitly comes. Import java.lang.star, is it required to write? No, implicitly comes. So java.lang package is a default package. It is implicitly imported in every Java program. Java.lang.object class is a default class and it is implicitly inherited in every Java class. .toString method implicitly called whenever you pass object or object reference as a parameter to a method. Now here CD nothing but object reference. CD nothing but object reference. I pass it as a parameter to println method. Then implicitly ToString method called. That is default method will call. Default means no need to write. It automatically comes. Say, are we writing import java.lang.star? Why? Default. That implicitly. Are we writing extends object? No, implicitly. Are we writing .toString? No, implicitly. Now, here, what I passed? CD. What is CD? Object reference. Whenever you pass object reference or object as a parameter, then ToString called. Then here I passed CD. Then this reference points to which object? Connection demo object. That class name printed. At hash code printed. Suppose if I write system.in. In what is in? Input stream reference. Input stream reference. I passed reference to println method. Then implicitly which method called? ToString method called. In refers one object, no? That object class name printed. See, right click, run as Java application. See what you are getting? Java.io.buffered input stream. So in refers buffered input stream object. But actually what we have to pass? Input stream. But what we are passing? Buffered input stream. Reason? Upcasting. Valid. So actually here scanner S equal to new scanner. Here we have to pass input stream. The actually constructor is like this, no? Public java dot io dot public java dot util dot scanner, which will take java dot io dot input stream. This is constructor. This is constructor. How when constructor is called? Whenever object is created. Scanner S equal to new scanner. Okay. Here we have to pass input stream reference. Okay. Now it is constructor. It is constructor. Is it accessible? Yes, because public. When constructor is called? Whenever object is created. How will create object? Scanner S equal to new scanner. Actually, what we have to pass? Input stream reference we have to pass. But actually, input stream reference we are not creating, already created. Input stream IN equal to new buffered input stream. They written. This is already written. Buffered input stream. They written. Input stream is a superclass. Buffered input stream is a subclass. Subclass object assigned to superclass reference. This concept is called upcasting. But this line, it is static public. It is public and static concept. So this line is public, static. This line where it is in system class. Java.lang.system. Now what is in object reference? Object reference. Scanner class constructor, what it takes? Can I pass in here? Yes, we can pass. In is object reference of input stream. We can pass. In can I call it as variable? Yes or no? Is it instance variable or class variable or local variable? Class variable. How do you know? Static. Then how to pass? Class name dot. That's what we are writing here. System dot in. Do you know? Like this. Internally like this. So actually scanner class takes input stream reference. But majority students, what they are doing? They are by heading. Scanner is equal to new scanner system dot in. Over. It is working, no? Working enough. So scanner S equal to new scanner. Scanner class constructor takes input stream. But input stream, can you create object? No. Why we cannot create? Abstract class. Input stream subclass. Buffered input stream. Can we create object? Like that created. But this is created in which class? System class. But this is given as static. That is the reason system dot in. That is the reason system dot in we are passing. So scanner class constructor takes input stream parameter. Input stream you cannot create object. Input stream subclass object we can create. No need to create. Already created in system class. That is as a static member they created. That is the reason system dot in we are passing. Now this in is a static member. How many ways to access static members? 4 ways. Directly, class name, object, object reference. How many ways not recommended? What are those? Don't use object, don't use object reference. When we can use directly? Same class. When we can use a class name? Another class. In is in which class? System class. In is in system class. My class is demo class. Can I access directly? That's what system dot in. That's the reason system dot in. Okay. See, we are writing one line only. In a one line, how many concepts are there you observe? Input stream inherited in buffered input stream. Inheritance is there. Buffered input stream object assigned to input stream. Upcasting concept is there. This is created as a static member in system class. Has a relationship is there. You studied no relationships? Is a relationship, has a relationship. System has a input stream. System has a input stream. Has a relationship. Inheritance is there. Upcasting is there. And like has a relationship is there. Static member is there. It is static member. That's what we are calling like this. Got it? So every day we are writing scanner is equal to new scanner system.in. Reason this is. Internally like this is there. Okay. Now this is scanner class internal concept. Now here with scanner class you can accept, you can write data dynamically. Okay. Even system.out.println, do you know? This one, because that is also internal concept. Println method belongs to which class? Which class? Print stream class. Print stream. Print stream, it is instance method or class method? So this is also you don't know. Understood. Now, println method, instance method or class method? You observe? It is very easy to give answer. Seeing that line only can give answer, no? So what I understood is, this line also you don't know, that I understood. System.out.println. Println method. Println method belongs to which class? Which class? Print stream class. Print stream class or output stream class or system class? See, different answers coming, you observe. Okay. Is it instance method or class method? How many people answer class method? What happened? Majority people given class method. It is very easy. If you are calling with class name, class method. You are calling with reference means instance method. Are you calling with reference or class name? Again, out is a reference or class? Reference. So it is instance method. You observe. Java dot, IO dot. See, Java P, Java dot, IO dot, print stream. See, how many println methods are there? 10 methods. 9 print methods. 19 methods are there. Method name same. Parameter list different. It is called overloading. Method overloading. Now, are these accessible? Yes. Are these instance methods or class method? How do you know? There is no static. There is no static, no? These methods, if you want to call, which class object required? Print stream class object required. But print stream object, we are not creating. Already created. That is available in system class. Here. What is out? Reference. Reference of which class? Which class? Print stream class. It is a member of which class? System class. Out, can I call it as variable? Instance variable or class variable or local variable? Class variable, because static. That is the reason system.out. With this out, println. Println is a method of which class? Print stream. For calling println method, which class reference required? Print stream reference. Print stream reference is a member of which class? System class. But is it static or non-static? That's what system.out.println. This line. But every day we are writing these two, no? Scanner class you are writing every day, system.out.println every day you are writing. Sometimes these questions also in interview they'll ask. But always people will give answer scanner is equal to new scanner system.in. But how it is working, they don't know. System.out.println, how it is working, they don't know. So like this. System.out.println. For calling println method, print stream reference required. Print stream reference only out. Out is a static member of system class. That is class variable. That is the reason with class name we are calling. Okay. Now here I want to accept data from dynamically through scanner class, and I want to display. I want to pass. I want to insert record in a database dynamically. See how to do you observe. First of all, now it is common code. Now, first of all, I want to accept data like a roll number, name, marks. I want to accept. How will I accept? Scanner is equal to new scanner. What do you write? System.in. We are writing system.in. Actually, what it takes? Input stream reference. Input stream reference only in. In is a member of that is static member. That's what system.in. Okay. After this, system.out.print. Enter roll number. Okay. Enter roll number. I'll accept roll number. For accepting roll number, which method you have to call? Next int. Next int method. So integer something roll number equal to s dot next int. Next int I accepted. Okay. Next system.out.print. Enter name. Okay. Enter name. Next return type string. Name equal to s dot next. Okay. Next system.out.print. Enter marks. Okay. Next integer float like a marks integer only. Integer marks equal to s dot next int. Now accepted. Roll number accepted. Name accepted. Marks accepted. This data we have to insert. Now first loading a driver. You have seen just now auto loading driver facility. That is no need to load. Next connection. Driver manager. Dot get connection. Now get connection 3 parameters. JDBC colon Oracle colon thin colon at localhost colon 1521 XC. Next system. Next manager. Okay. Now connection established. Now if you want to insert dynamically data, statement record or prepared statement record or callable statement record, go for prepared statement. Prepared statement, something PSTMT equal to con dot prepare statement. Dynamic query. Dynamic query. Insert into student values. Okay. Question mark, question mark, question mark. Now we have to already we accepted data. That is we have to set. What we have to write? Prepared statement dot set int. Roll column number 1. Here roll number. Next PSTMT dot set string. Roll number 2. Column number name. Okay, it's okay name. Next PSTMT dot set int. Column 3 marks. Okay. After that execute update. PSTMT dot execute update. Okay. Now you can write system.out.println one record inserted successfully. One record inserted successfully. Okay. Now try catch blocks. Control Shift O. Driver manager class importing these all required. No. No. Okay. This is on program with scanner class. You observe. Right click, run as Java application. See, enter roll number. You observe SQL already records. You can check. Connect. Select star from student. So up to roll number 13 is there. Okay, I'll insert 14. See, roll number 14, name, table N, marks 99. Okay, this missing comma. What is it? Insert into. Okay. Okay. Now right click, run as Java application. Okay. Say roll number 14. One record inserted successfully. You can check. Okay, roll number 14 inserted. So scanner class means you can use like this. But actually, this scanner class buffer reader, no one will use. Reason, this where we are entering at the command prompt, but graphical user interface is required for user. In real-time projects, command prompt will not appear. Okay, buffer reader, system.in.read, data inputs, these all will not be there. User will enter data in browser. That is HTML program. That is next topic onward, that one only every day. We'll accept the data in browser. Now, this is main method also today last. Tomorrow onwards, no main method. Okay, main method is not required. Now, you will execute through browser server. It is complete different. Now, further main method is not required. Tomorrow onwards, no main method. Complete programming is different. So, what we have to do is tomorrow onwards, today onwards only. Now, I'll start with solids. Say, one solid program we have to write. For that, one XML program we have to write. Later, we have to create a WAR file. That WAR file, we have to start the server. We have to deploy in server. We have to configure. After that, we have to open browser. From browser, we have to send request. Then server side executed. That output comes in browser. Now, no command prompt, no SQL prompt, no this main method. These are not required. It is complete different. Real-time Java starts from Solets. Up to core Java, JDBC, same style will be there. But Solets onwards, it complete new. Complete new. Frameworks, one more style. Okay. This scanner class, many people asked, that's what I explained. Actually, this is not required. Right, this one? 1 minute. Program to demonstrate prepared statement with scanner class. Write this program. Program to demonstrate prepared statement with scanner class. Note program to demonstrate prepared statement with scanner class. Program to demonstrate prepared statement with scanner class. Program to demonstrate prepared statement with scanner class. Two packages we imported. One is IO scanner class purpose util package. One more SQL package. Online students, you write the notes. End of the session, I'll clarify your doubts. How many editions of Java is there? 4 editions. Java SE, Java EE, Java ME, Java FX. Java FX. Okay. Core Java is a part of which edition? Java SE. JDBC is a part of Java SE only. Already given starting. Solids comes under Java EE. Now Solids I'll teach. For Solids onwards, Java EE perspective required. Now you are using Java perspective. This is in Eclipse. Java EE required. Okay. Here, whatever we are using now, perspective is called Java perspective. Next is Java EE perspective required. Java's perspective doesn't work. Okay. If already Eclipse for Java install means you upgrade to Java EE. Otherwise, uninstall, you install Java EE perspective. Okay. Now Java EE perspective required for Solids, because Solids onwards Java EE. JDBC topic, reflection API, these two comes under Java SE. Remaining all topics comes under Java EE. That is starting introduction, first class only given. Okay. Is it over? Now I'll start Solids up to here JDBC. Okay. Is it over? Not over? The JDBC also required in Solid program, because Solid JDBC I'm going to combine. Don't forget JDBC. Is it completed up to here? Next, write it. Solids. You studied JDBC. What is JDBC? Not full form, not full form. Definition. JDBC is a specification for developing database applications with Java programming language. Now, Solids. Solids is a specification for developing web applications with Java programming language. Solids is a specification for developing web applications with Java programming language. Solids is a specification for developing web applications with Java programming language. Solids is a specification for developing web applications with Java programming language. Say, JDBC is a specification. Solids is also specification, but purpose different. That is rules and guidelines. It is also rules and guidelines. Purpose different. That specification for developing database application. This specification for developing web applications. Now, what is specification? Rules and guidelines. Okay. That later we'll see. First web application we'll see. Next, write it. Web application. A web application is a distributed applications. A web application is a distributed application which runs on browser and server. A web application is a distributed application which runs on browser and server. A web application is a distributed application which runs on browser and server. Again, what is distributed application? An application that is installed on one computer and runs on many computers is called as distributed application. An application that is installed on one computer and runs on many computers is called as distributed application. An application that is installed on one computer and runs on many computers is called as distributed application. See, suppose 5 computers are in one network. 5 computers are in one network. Now, 5 computers connected together as a one network. In this computer, MS Office software installed. MS Office software installed. This MS Office can access here? Can access? No, it is not possible. MS Office, not a web application, not a distributed application. MS Office standalone application. Wherever you install, there only possible. Beside system, you cannot access. Okay. MS Office, you cannot access in beside system. You can access in the system only, because that is not distributed application. Now, suppose you install here, you can access here also, here also, here also, here also, here also. Then we can call it as distributed application. So, if the application installed on one computer and runs on many computers, that is called distributed application. If any application installed on one computer and running on many computers, that is called distributed application. Now, example, Google. Is it in my computer? No, Google is not here, but you can run here. No, Google installed in USA computer, but you can access here also. That is running here also. So, installed in one computer, running on worldwide many computers. So, that is distributed over the world. So, even installed here, you can access here. It is also called distributed. In core Java, network programming you studied, that is also distributed. That is also distributed, because LAN possible, but internet not possible. Internet purpose solid. Whatever you studied in core Java network programs, those are LAN programming. But LAN programming also distributed programs only. One program to other program you are accessing means distributed. So, it is local area network. 5 computers connected together and here installed, you can access here. It is called distributed. It is called distributed. But it is not possible to access worldwide. But still it is called distributed. So, distributed applications also 2 types will be there again. Like a network application, internet applications. Both are distributed. Network, only LAN within a network. Internet, worldwide, any network. Okay, like that. So, here what I given see, Soulets. Soulets is a specification for developing web applications, I said. For developing web applications, I said. Web application is called distributed. When we'll call, which runs on browser and server, we'll call it as web application. But whatever you studied in core Java network program, it is not executed in browser. It is only operating system only executed, but we can call distributed. But when we will call web application, browser and server, it is distributed over the world. N number of people at a time can access that type of application. One program, suppose if you write one welcome program also, that program worldwide accessible. Worldwide, that type of program is web application. Installed on one computer, runs on many computers. Say Google, Gmail, Yahoo, Facebook, these all web applications. Like worldwide, crores of people are accessing. Say Google, within a 1 minute, 2.5 crores of requests coming to Google. Within a 1 minute, not in 1 day. 1 minute only, not 1 hour also. That means within a 1 day, how many requests are coming to Google? Some millions of crores. Within a 1 minute only, 2.5 crores of requests coming to Google. Worldwide, 2.5 crores of systems it is running within a 1 minute. Those many requests are coming. That is distributed over the world. That type of applications purpose only Java came. In that Java, this topic only. It is the first specification. With this knowledge only, JSP becomes easy. With this knowledge only, Spring Framework becomes easy. Like that. Based on like learning style. First specification in Java, Servlets. Okay. Later JSP came. Later JSF came. Later Struts came. Like that, so many came. Okay. So Servlets nothing but what purpose? To develop web application. What is web application? It is a distributed application which is running on browser and server. So tomorrow onwards, we are not using command prompt. Tomorrow onwards, we are not using here. Browser we use. Browser and server. And it is distributed over the world. Okay. That type of program we are going to develop. Today onwards, this Servlets onwards, Java is very interesting. Okay. But whatever you studied up to JDBC, that knowledge required. Don't forget. Okay. Tomorrow we'll see continuation.